Hello everyone. Today we shall discuss about the organic reaction mechanism. There is no organic reaction which take place without a reagent. Therefore, we shall discuss and learn about the types of reagents which are going to take part in the reaction mechanisms of organic chemistry. They are free radicals, electrophiles, nucleophiles. We shall now proceed with the free radicals. They are odd electron particles. They are generated by sunlight and heat. Example, this is heat and this is sunlight. This is a free radical. A free radical is highly reactive with a short half-life. Therefore, it takes part in a chemical reaction by following a chain till the reactants are exhausted or the conditions are ceased. So now I would like to discuss the reaction mechanism where the free radical will take part. An example is halogenation of alkanes. Alkanes are the saturated hydrocarbons which are susceptible for free radical substitution reactions. So this is an alkane, halogen, heating and sunlight, they are the products. This is haloalkane, this is hydrogen halide. Now let us discuss about the reaction mechanism which plays an important role and more significant aspect of organic chemistry. So here we have several steps. chain initiation, where the free radicals are generated. Chain propagation, these are the reactions in which you will find the reactants at the product side. Therefore, they repeat each other till the reactants are exhausted or the conditions are ceased. Therefore, we call this reaction as a chain reaction. This is free radical. This is also free radical. These two reactions repeat each other. Therefore, it is called as a chain reaction. However, the reaction can be terminated when the reactants are exhausted or the conditions are ceased. So therefore, we have chain termination process. Here, the two halogen free radicals react with each other to form halogen. Two alkanes react with each other to form higher alkane, or this. So this is the chain termination. Now let us move towards electrophiles. These are electron deficient particles. So their generation is, for example, if you take a halogen, you need to take here a Friedel-Crafts reagent. Friedel-Crafts reagent to form. So this is an electrophile. So how does it take part in chemical reaction? Let us see. Now we can take an example of benzene, that is halogenation of benzene. Benzene is susceptible for the electrophilic aromatic substitution. Benzene is a hexagon with the alternating double and single bonds having a resonance. So here we have this is benzene. So here if you take halogen, Friedel-Crafts reagent, Lewis acid, so this is halobenzene, substituted product. So this is called as electrophilic aromatic substitution. Now, let us discuss about the reaction mechanism. So, the electrophile is formed due to the heterolytic fission of the covalent bond. So this is an electrophile. Now this is benzene, hydrogen. A resonance takes place as soon as the electrophile attacks on benzene. So this is the one resonating structure or canonical structure. So this undergoes resonance. So there is a rule here, higher the resonance, more is the stability. Higher the resonance, more is the stability. Higher the resonance energy, more is the stability. So here there are these three are the resonance structures. So finally what will happen? One of the resonating structures will lose hydrogen ion, to form the substituted benzene. So this is hollow benzene, which is a substituted product. And now third, nucleophiles. Nucleophiles are the electron-rich particles. To take an example, we can go for addition reactions of carbonyl compounds. Example of nucleophilic reaction is addition of hydrogen cyanide. So this is carbonyl compound, this is hydrogen cyanide. So it is undergoing heterolytic fission where the bond pair of electrons is unequally divided. So now this is the product cyanohydrin. The name of a reaction is given on the basis of the reagent.